Hello, this is Mrs. Salisbury. Today I'm going to talk about reference angles and how to find them in both degrees and radians. If you like this, don't forget to subscribe and like. So before we talk about reference angles, I want to make sure that we remember the context in which we're talking about angles in trig. And these are going to be angles in standard position with the initial side on the positive x-axis. So when we talk about an angle, let's say our terminal side is somewhere right here. We are talking about measuring it from the positive x-axis all the way around this way if it's a positive angle. So for here, we're going to be talking about mainly positive angles. So let's say that our angle here is 125 degrees. We want to find our reference angle here because this is the small angle with the terminal side and the x-axis. If we use 125, even though that is also with the terminal side and the x-axis, it's an obtuse angle. So we're always looking for the small angle. So notice that these two angles, my 125 and my theta, add up to a straight line. So the other thing that we want to point out is that if we're starting on the positive x-axis, that's 0 degrees, a right angle would be 90 degrees, and my straight line would be 180 degrees. And then if I go another 90, I've got 270 degrees down here at the bottom, and then I would get back to 360. So the two angles I have make a straight line adding up to 180 degrees. So if I want to know what this angle is here, I can take my 180 and I can subtract my 125, and that's going to give me my reference angle of 55 degrees. So this strategy will work for any angle in quadrant 2. So let's try another one. Let's say we have 110 degrees. We want to think along the same lines as before. This 110 and this little angle theta make a straight line, which means they have to add up to 180. So I can take my 180, subtract my 110, and I get my reference angle of 70 degrees. So you try. Let's say I have an angle of 165. Find my reference angle. Go. Go ahead and pause the video and try it on your own. So 180 minus 165 is 15 degrees. So if I add 165 and my theta of 15 degrees, I get my straight line 180 degrees. So let's try another one where we are in a different quadrant. Let's try this angle here. Notice that for this angle, we went past 180. We went 180 degrees and then more. So to find this reference angle, we're going to need to take this entire angle and take away this 180 degrees. So we're going to pretty much need to eliminate this part so that we only have my reference angle right here. So we do that by subtracting 180. So let's say, for example, that this angle, the entire angle, was 210 degrees. So that means we went 180 plus another how much to get to 210? We went an extra 30 degrees. So what we essentially did is we took our 210 and we eliminated that 180, so we're just left with that acute angle of 30 degrees. And that will work for anything in the third quadrant. So why don't you give it a try? I'll give you a couple examples that you can try. So try this angle here, which I'm going to call 250. Pause it and give that a try. So for this angle, we went all the way past 180 and some angle more. So we have to figure out how much past 180. So we're essentially eliminating 150 and only looking at this angle here that's left. So we can take our 250 minus 180 to get our reference angle of 70 degrees. Now if we're in quadrant 4, let's say right here, we can think about that a little differently. So let's say we're looking for this reference angle. It's going to be that acute angle between the terminal side and the x-axis. So to get here, we normally go all the way around this way. So let's say this is 300 degrees. So we can think of it as how much further would we need to go to get all the way up to 360. So we're looking for this angle here. So to go from 300 to 360, that's another 60 degrees. So the other thing we can do is take 360 and subtract that angle to get our reference angle. So let's say that this was 340. So try to find the reference angle for 340. Go. So we subtract 340 from 360, we get 20 degrees. So our reference angle is 20 degrees. So let's try doing the same thing, finding our reference angles, but with radians instead of degrees. So for radians, we still start at the positive x-axis, so this would be 0 radians. And we know that 180 is equivalent to pi. So that means if we're at 90 degrees, we are halfway between 180 and 0. So this would be, or in this case, pi and 0. So this would be half of pi, or pi over 2. If we continue all the way around, we're adding another half pi. So this is going to be 3 pi over 2. So we want to keep that in mind as we're finding our reference angles for radians. So let's say that we have an angle here, and let's say we call that 3 pi over 4. So we want to think about how much further to get to 180, just like we did before, except in this time we're thinking about how much further to get to pi. We know that this 3 pi over 4 angle and our reference angle have to make a straight line, so they have to equal pi. So we can do the same thing we did before, except instead of saying 180 minus the degree measurement, we're saying pi minus the degree measurement. So here, we've got pi minus 3 pi over 4. And it's helpful if you're not very good with fractions, just to recall a couple fraction rules. When we're adding and subtracting fractions, we have to get the same denominator. So I'm going to turn that pi into 4 over 4 because that equals 1. So that leaves me with 1 more pi over 4. So my reference angle then is just pi over 4. Let's look through another example. Let's say we have 4 pi over 5. So we know that a straight line equals pi, so we know that 4 pi over 5 and whatever our reference angle is has to add up to pi. So we can take pi and subtract 4 pi over 5 to get our reference angle. And again, we want to get common denominators, so I'm going to make that 5 pi over 5. So that leaves me with just 1 pi over 5. Now, it's not always going to be 1 pi over something. Let's look at an example where it's a little different. Let's say our angle was 7 pi over 10. Well, same thing, it's got to add up to pi because pi is one straight line. So we can take pi minus 7 pi over 10. We still need our common denominators, so I'm going to do 10 over 10. So that leaves us with 3 pi over 10. So my reference angle is 3 pi over 10. Let's look at an angle in quadrant 3. Let's say this is 13 pi over 10. So my reference angle, as you know, is going to be this little acute angle between the terminal side and the x-axis. So if we look here, it doesn't make sense to subtract from pi because we actually went an entire pi. We went an entire straight line, which is pi, plus some more. So we need to pretty much, just like we did with the degrees, eliminate this part of the graph. Before we eliminated 180, now we're eliminating pi. So we need to take our 13 pi over 10, and we need to subtract that pi from it. And we still need to get common denominators, so we still need 10 over 10. So 13 pi over 10 minus 10 pi over 10, and we get 3 pi over 10. And so our reference angle is going to be 3 pi over 10. Let's try one more in quadrant 3. Try 4 pi over 3. Go ahead and pause it and give that a try. So 4 pi over 3, I'm looking for my reference angle right here. So I went an entire pi plus some more. So to find my reference angle, I need to take this 4 pi over 3 and subtract pi to get how much extra I went past it. So common denominators, and so I end up getting just pi over 3. Let's try a couple in quadrant 4. Let's try 11 pi over 6. So 11 pi over 6 is almost to 2 pi. So we're looking for this theta. So 0 pi we can also think of as 2 pi. Just like we can also think of 0 degrees as 360. So if half a circle is pi, a full circle is 2 pi. So we're almost to 2 pi. So we have to see how much further we need to go to get to 2 pi. So here we can take our 2 pi and we can subtract 11 pi over 6. Now here, since we're working with 2 pi, we still need denominator of 6. But think about how we turn 2 to have a denominator of 6. We need to double that on top to get 12 over 6. So here, I'm going to make that 2 pi into 12 over 6 because that's equivalent to 2 pi. So now 12 pi over 6 minus 11 pi over 6, and I get 1 pi over 6. So my reference angle is pi over 6. Let's do another one. Let's say I've got 8 pi over 5. So here, I'm almost to 2 pi. I just need to figure out how much further I need to get. So I'm going to take 2 pi and subtract 8 pi over 5. Now, I know that 2 is the same as 10 over 5, so I can change that 2 to a 10 over 5 so that I can get my common denominators. Now, 10 pi over 5 minus 8 pi over 5, and I get 2 pi over 5. So my reference angle is 2 pi over 5. So hopefully that helps a little bit getting some more practice. So really it's just practice, practice, practice. And I will be posting some more videos soon. Don't forget to like and subscribe.